Hey everyone, welcome back to Prep Academy. This is Mimi Hannah James. So, as we have already started our math preparations, and it's high time that we indulge into the high yielding topics. Today, in this video, we will be dealing with that topic calculus. Two types of calculus are there, that differential calculus and integral calculus. So, in this video, we will be focusing more on differential calculus and its applications. So, what is differentiability? Before that, what is continuity? A function can be differentiable only if it is continuous. So, what is continuity? Okay, for a function, if any function can be expressed graphically. Okay, suppose f of x is equal to x square is the function. So this is a function. So any function that can be expressed graphically, when we express it graphically, it should be a continuous function. Okay, so for f of x is equal to x square, it's a parabola, so it will be like this. So it's a continuous, it doesn't stop anywhere. Or see, this for this graph, here it started from here and stopped, and then it started from here and then it stopped. See, this is not a continuous function. Okay, there are gaps in between them. This is not a continuous function. So graphically, a continuous function mean that if we can draw the graph of the function without even taking the pen, then it is a continuous function. See, if we can draw like this if this is a graph of a function, then it is a continuous function. Okay, that is what we mean by continuity. So that's the geometrical aspect. So how do we define it algebraically? How do we define a mathematical definition for continuity? So if a function needs to be continuous at a point x is equal to c. So we have the domain, and if c is a point in the domain, then if we want the function to be continuous there, that means there is no jump. Okay, that is from here. So when the example was this, from here it jumped below, and then after from here it took a jump here also. So it's not a continuous function. So limit of x tending to c minus f of x is equal to limit of x tending to c plus f of x equal to f of c. This is the mathematical definition for continuity. So if any function satisfies this, then it's a continuous function. So for a function to be continuous, three conditions should be satisfied. That is, f of c should exist. We want to have a value of the function at the point c, that is f of c. So f of c must exist, and both its left hand limit and right hand limit should exist, and they should be equal to this actual value. So that is limit extending to c minus. What do we mean by that? So we have the point, if this is the number line and this is our point c. C minus means it's a point very close to C, but not C, but very close to C, onto the left side of C. Okay, which is on the left side of C, very close to C. And C plus means very close to C, but on the right side of C. Okay, so such points, that points are called. So when we tend x towards C minus, that is, we are reaching C toward from the left side. That this means the limit LHL, and RHL means we are reaching C from the right side. Okay, so it means that the function values of c and the point just before it and just after it should be equal. Isn't it correct? Okay, so if that is correct, then that means the function is continuous at that point. So if a function is continuous at every point in an interval, so we have this interval, if the function is continuous at all the points c1 c2 c3 everywhere, then the function is said to be continuous everywhere through the interval. Okay, so every polynomial functions we have took here, the function f of x is equal to x squared. So here 0 plus means 0 plus is a positive quantity, right? Limit extending to 0 plus means 0 plus is value which is on the right side of 0, that is positive. But when extending to 0 minus, it is on the left side, that is it's a negative value. So that's what we mean by 0 plus or a plus or c plus, c minus, etc. So f of x is equal to x square. This is a polynomial function. Every polynomial function is continuous. Every polynomial. Similarly, every logarithmic function and exponential function, sine and cosine function, sorry, not logarithmic, and sine and cosine functions, they are all continuous everywhere in the domain. Okay, now that we understood continuity, we can get to the topic differentiability. So, if a point is continuous at a point, point, if a function is continuous at a point, then we can check for its differentiability. But differentiability in the in the graphical aspect, it means that the graph is a smooth graph. That is, if the graph, this is a graph of a function, is it smooth? No, because it has a sharp point here. Okay, it has a sharp point here. It's not a smooth function. So this is not a differentiable function. Whichever function's graph is it, the function is not differentiable. So differentiability means the graph should have a smooth graph. Okay. Continuity was we have to be able to draw the graph without even taking the pen. It should be continuous. There shouldn't be any point of discontinuity. Differentiability means the graph should be a smooth graph. So there also, for mathematical definition of differentiability, for a function to be differentiable at x is equal to c, if the LHD and RHD, that is the left hand and right hand derivatives, should be equal. Okay, so these are the definitions for left hand derivative and right hand derivative. Okay, so limit h tending to 0, f of c minus h minus f of c by minus h, and RHT is limit h tending to 0, f of c plus h minus f of c by h. So this you have to know. Then we have the differentials of many functions. All of this we have actually already learned in our class 11. So all of these values you have to by heart. Then only we will be able to differentiate functions fastly. So if a function is differentiable, then obviously it is a continuous function. Okay, only if it is continuous we can differentiate a function. Then that's it. So all of these values, x raised to n, k, e raised to x, a raised to x, log x, all of these values you have to know. Okay, then product rule. So for differentiating a function, we have, like, if we have the product of two functions, suppose x square into sine x, this is the function that we want to differentiate. Okay, d by dx of x square into sine x. How will we do that? It is the product of two function x square and sine x. So the formula is f dash into g. We first differentiate the first function, then keep the second and keep the first and do the differential of second one. So that's this product rule. That is, we differentiate this. What is the differential of x square? It is 2x. 2x, correct? Because for differential of x raised to n is n x raised to n minus 1. So differential of x square is n, here it is 2, x raised to n minus 1, it is 2 minus 1, that is 1. Okay, it is 2x, and then we keep sin x there, plus we are using the product rule, plus sin x, differential of sin x is cos x, and keeping the x square there. So this is the, that is x square cos x plus 2x sin x. This is the differential. Okay, this is how we differentiate the product of two functions using this product rule. Similarly, we can differentiate the quotient of two functions, that is quotient rule, using quotient rule, if f of x is on the numerator and g of x is on the denominator, the formula for finding the differential is f dash g minus, okay, in the product rule it was plus, but here it is minus fg dash divided by g square. Okay, on the denominator there is a square of the g function. Okay, so there also we can try the same question actually, x square by sine x. Let's see, d by dx of x square by sine x. So these are two functions which are like p of x by q of x, which are in the form of divisions. So from this rule, f dash, that is f is x square. So x square, differential of x square is 2x into g is cos x minus, here also it is, we keep, sorry, we shouldn't have done that. We keep sin x like that, correct? 2x into sin x minus x square into the differential of sin x is cos x by sin square x, that is the denominator function should be squared here in the rule. Okay, so this is the quotient rule. This is how we differentiate the quotient of two functions. Then chain rule is there, the functions of functions, that is if we have some functions, combinations of functions, for example log of log of log of x raised to 5. Okay, this is a big function. It has a complex function, that is there are many functions inside a function. So that the function inside log is of another function, and the function is inside this is another log, and yeah, so we have a continuous functions of functions method. So what we do is we actually differentiate the function which is on the outside first. Okay, so d by dx of log x raised to 5. So we first take this log function. What is the differential of log? Differential of log x is 1 by x. Okay, but here we don't have log x, we have log, and in the place of x it is this big complex function. Okay, so 1 by x, we substitute that 1 by, here in the place of x we have this, so 1 by log x raised to 5. Okay, into multiply, that is what we mean by chain rule. We multiply, we don't stop there, we multiply it again and differentiate the next function which is inside to it. Okay, that is log, this log, the differential of this log is, that is also 1 by x, so 1 by log x raised to 5, 1 by log x raised to 5, and again this log comes. So the differential of log x raised to 5 is 1 by x raised to 5 into 1 by x raised to 5. Is it over? No, it's not, because we have x raised to 5. So the differential of x raised to 5 is x raised 5x raised to 4 using this x raised to n formula. Okay. So after cancellation, so here the x raised to 4 and x raised to 5 will get cancelled, and we have 5 by x log x raised to 5 log x raised to 5. So that is the differential. So that is what we do by chain rule. Okay, so that is if we have a function, we can differentiate the composite functions. Then implicit functions, we are also dealing with implicit functions in this chapter. That is, in some cases we can't, if we have y is equal to something, we can easily differentiate dy by dx. Fine, we can easily find dy by dx just by differentiating. So if this is the question, can we separate it as y? Can we write it as y is equal to something? No, it's impossible. So what we do is we just differentiate the given equation. That is, if it is x square plus xy plus y square equal to 100, we differentiate it. The completely differentiating it with respect to x. So for x square, we becomes 2x plus, for xy, that there we have to use product rule because x is a function, y is a function, it is a product of two functions, so we have to use the product rule. So the differential of x is 1 and y is kept there, plus we keep x and differential of y is dy by dx plus y square. For y square it is 2y into dy by dx. There also we have applied chain rule. Okay, we differentiated y, the square function, that is 2y, and the differential of y. Okay, another function was inside there. The differential of y is dy by dx. Okay, so that is equal to and minus 100. The differential of a constant is 0. So that's it. So from this, we isolate dy by dx. That is, we have dy by dx common for both of these terms. So we take dy by dx outside of them. That is, and remaining it is x plus 2y equal to, and taking these both of these to the right side of the equation, we get minus 2x minus y. And then taking this also to the right side, we get dy by dx is equal to, taking minus outside, so minus 2x, so 2x plus y by x plus 2y. So this is the differential. So we got dy by dx finally. Okay. Then inverse trigonometric functions are there. All of these values you have to know for sine inverse x, cos inverse x, tan inverse x, cot inverse x and all. And then exponential and logarithmic functions. The differential of an exponential function e raised to x is e raised to x itself. Log x, for log x it is 1 by x, that we have already did here, right? Okay, log x is 1 by x, and some properties are there. This you have to know. Only if you know this, you would be able to do the logarithmic differentiation. Okay, when do we use this logarithmic differentiation? Because if we have, for example, how can we differentiate this function x raised to x? So for these type of differentiation, we use logarithms, because this can't be, we don't have a standard form for these type of differentials. That is, we can't use x raised to n, because here x raised to n means in the power it should be a number, but here in the power is also a function. So whenever we have a function and two functions as the base and the power, that is f of x raised to g of x, or if it is a product of many complex terms, or if we mean cos x into cos 2x into cos 3x into cos 4x. So there also it is a product of many complex functions. So in these two cases, we will be using logarithmic differentiation, because otherwise we don't have any options. So there we first apply log. So let me take this example, x raised to x. Suppose we have the function x raised to x. So there we take the logarithmic differentiation. We take log on both sides. First step, log. That is log y equal to log x raised to x. Okay. So now there comes the role of these properties. So log of a raised to b here is b log a. We can put this b here. That is b log a. So there we write, here it is b, so here it is x log x. Now we can differentiate both sides. Okay, on differentiating on both sides, we get log y, differential of log y. Differential of log is 1 by, okay, log x is 1 by x, so log y is 1 by y into. Then y, differential of y is dy by dx equal to. Then x log x, there we have to use the product rule. Okay, differential of x is 1 into log x, we keep it there, plus differential of log x is 1 by x into x. So x and get cancelled and we get 1. So it is log x plus 1. So 1 by y dy by dx is log x plus 1. We wanted dy by dx. So there dy by dx is equal to log x plus 1. This divided by y when going to the other side becomes into y. Okay, so this is how we do the logarithmic differentiation. Where do we use this? In products, in functions which are complex functions, or like if the power, if a function is on the power of another function, okay, x raised to x or sin x raised to cos x, there also it is the two functions, the base and the power is both functions. So in such cases, and for those continuous products, cos x into cos 2x into cos 3x into cos 4x into etc etc etc, for such problems also we use this logarithmic differentiation. And yeah, this is logarithm of a raised to b is b log a, log of a by b is log a minus log b, log of ab is log a plus b, log a plus log b. Okay, then, and in the chapter we had parametric forms. Okay, so if we have two functions f of t and g of t, then if we want to differentiate dy y with respect to x, here we have y which is dependent to t. Okay, we can only differentiate y with respect to t, but we want y with respect to x. So there we use this parametric form. Okay, so it is dy by dt by dx by dt. For example, if x is equal to t square and y is equal to sine t, so what is dy by dx here? That is the question. What is dy by dx? So for that, we find dy by dt and dy by dx by dt first. Okay, so dy by dt, there is d by dt of sine t, that is cos t, and dx by dt there is t square, that is 2t, and therefore dy by dx is this. So here in the numerator we have dy, so we write dy by dt divided by dx by dt, that is cos t by 2t is the answer of dy by dx. Okay, and we had second order derivative. Second order derivative means that we just take the derivative two times. We first find differential and we got dy by dx. We differentiated the answer once again. Okay, so that is what d square y by dx square. Okay, and d square y by dx square is not equal to dy by dx. Many of the students make this mistake because dy by dx, this means we have differentiated only one time and just took the square. Okay, you can work it out for yourself and see if it is true or not. And here it is the product. This is the differential of second differential. Okay, this we took differential two times, so that's the difference. And if you know these basics, if you know how to differentiate a function or how to differentiate different types of functions, you can simply study these application of derivative chapter. So in that chapter we will be dealing with some rate of change problems, increasing decreasing functions, and the maxima minima problems, and then absolute maxima, absolute minimum. Only this much is there. Okay, so the first thing was a rate of change. That is, if we have one quantity changing, then we want to know, okay, on the basis of this, or if this is changing in this rate, then we want to know if the other, how fast or how slow is the other quantity changing. So that we will do a problem. There we most questions are on this area change and volume change. How much, if we are extending the length by this rate, how much the area changes, how fast does the area changes. So that's the rate of change. And decreasing and increasing function, so you have to know all these working rules. Okay, these are the working rules. So if f of x is a function, okay, f of x is equal to x square is a function. How do we know that if it is an increasing function or a decreasing function? What is increasing and decreasing function? Increasing function means the definition that you have to know, which might be asked for MCQ question. Okay, all of this definition, because you will be asked to pick one which is the correct answer. Okay, so for increasing function, okay, for increasing function, if x1 is greater than or equal to x2, then f of x1 is also greater than or equal to x2, and x1 is less than or equal to x2, f of x1 is also less than or equal to x2. It just follows the pattern. If this is greater, function is also greater. If the value is lesser, function is also lesser. Where decreasing function means it does the opposite thing. If x1 is greater than or equal to x2, that means f of x1 is less than or equal to f of x2. So then the function is a decreasing function. So x1 is less than or equal to x2. That means f of x1 will be greater than or equal to f of x2. If it shows the opposite characters, then that is a decreasing function. Okay, so these are the definitions. But if we want to know if a given function is decreasing or increasing, we want a working rule. This right here is the working rule, because maybe always it is hard to find it using these. We will have to take all the values which are greater and it will be a mess. So we have a clear uh, path, clear working rule to determine which interval, or if it is increasing. If it is increasing, wherever it is increasing, we have to use this. So let's just do this. F of x is equal to x square. So f dash of x, we have to find f dash of x. So here f dash of x is 2x. Then we have to find the critical points. That is, we have to equate f dash of x equal to 0. Okay, first find f dash of x, then equate it to 0 and find x value. So from here x is equal to 0. So from in my question, x equal to 0 is the critical point. Yeah, there might be a change from there. Before and after, there might be a change. There is only one critical point in this question, but in some other questions, there can be 1, 2, 3, or many more critical points. Okay, so in this particular question, there was only one critical point. So after getting the critical point, we want to draw the number line. Okay, this is a number line from minus infinity to infinity, and we have to point where the 0 comes, maybe here. Okay, so this 0, this critical point, divided our number line into two different intervals. Correct? Minus infinity to 0 and in 0 to infinity, two intervals. So there we want to check if the function is increasing in each of these. Okay, we have to take them separately and we have to check if they are increasing in each of these. Okay, so how do we know that? We just take a random number from this. So from the interval minus infinity 0, we can take the number 1. Okay, so minus 1. We find the f dash of x, f dash of minus 1, it is f dash is 2x. So 2 into minus 1, it is minus 2. So this minus 2 is less than 0. Okay, if f dash of x is less than 0, then it is a decreasing function. So in this interval, the function is a decreasing function. In the right interval, we are taking another value 1, okay, or 2, or whatever. If I take 2, f of 2 is 2 into 2, 4. This is greater than 0. That means the function is increasing function. Okay, if f dash of x is greater than 0, it is increasing. Okay, so we found the critical point, we marked it in a number line, and we divided the thing into 2, and we have right here minus infinity to 0, two intervals. So we took a random point from the interval 1 or minus 1. Okay, from this interval it was minus 1. So we just substituted in the f dash of x, not in the f of x. We substitute in the f dash of x. Okay, in the f dash of x, and we found that the value, f dash value, is less than 0. If it is less than 0, then it is a decreasing function. If it is greater than 0, it is a increasing function. Okay, so here in this interval is decreasing and increasing. So that's how we find the function is increasing or decreasing. Okay, then we have this maxima and minima. Maxima and minima, to find the maxima and minima of a function, we have two tests actually, first derivative test and second derivative test. So we actually prefer doing second derivative test. Okay, if we want to know, if we are asked to find the maxima and minima, we prefer second derivative test. You have to go to first derivative only if second derivative fails, because second derivative test is much faster and simpler on the side. So if there are cases, if when it fails, so if it fails, you have to go back. There's no other option. You have to go back to first derivative test. So for second derivative, so what is this maximum and minimum? Sorry, I didn't say that. Maximum and minima actually means if the function, there is this function f of x. So the function takes the maximum and minimum value the function can take. That is maxima and minimum. Okay. So we will be finding where this local maxima and local minima means the point where the function will be maximum, the point where the function will be minimum. So that points are the local maxima and local minima. So the second derivative test for finding that is, first we differentiate the function. Okay, first we differentiate the function and find the critical point. How do we find the critical point? Just by equating the differential, first differential to equal to 0. Okay, so now we got the critical point also as C. Okay, and then we differentiate the function again. It is a second derivative test, so we need two derivatives. So we differentiate it again. So it is f double dash of x we found, and we substitute this critical point in the second derivative. Okay, in the second derivative. So if the second derivative value is less than 0, it is a point of local maxima. If it is greater than 0, it is a point of local minimum. If it ever comes to 0, that means the test is failed. You have to go to the first derivative test. So like if I can take the same example, f of x is equal to x squared plus f of x is equal to sin x, let's take. Okay, so for sin x, we have this, we first differentiate f dash of x is equal to cos x. Okay, we got the cos x, then we equate cos x to 0, and then the value of cos x, we want to find the x value, that is a critical point. When cos x is equal to 0, what is x? So cos 90 is 0, so x is equal to pi by 2. Okay, so x equal to pi by 2 is the interval, it's the critical point there. So we draw this, so when we have this um, interval, it is pi by 2. So what do we have to do? So okay, this was for the increasing and decreasing functions. Here we got the critical point, and now we have to differentiate the function again. F dash of x, we got cos x, and f double dash of x, it is the differential of cos x is minus sin x. Okay, and then we are substituting this f double dash of the critical point, that is pi by 2, that is minus sin pi by 2. Okay, so here sin pi by 2 is 1, so minus 1. So minus 1, it is less than 0. That means the function sin x has a local maxima. Okay, if it is less than 0, it has a maxima. It has a local maxima at, what was the critical point? X equal to pi by 2. Okay, that means the function has a local maxima at x is equal to pi by 2, and the maximum value is what? How do we find the maximum value? We have x is equal to pi by 2, and we have f of x. So f of x is equal to sin x. So f of pi by 2 gives the maximum value. So sin of pi by 2, that is 1. That is the maximum value. Okay, that's the second derivative test. And we have the first derivative test also. So first derivative test is used mostly when the second derivative test fails. That is, if in these cases, if f double dash of c is equal to 0, then the test fails. So in such cases, we will be using this first derivative test. Okay, so in the first derivative test, the procedures follow up until critical point. Finding critical point, we differentiate the function, find f dash of x, and equate them to 0 and solve for x. That is, we find the critical points. So we will be checking for the sign, changing of the sign. So when if x is equal to 0 is the critical point, we have to see if when the point passes through 0, if it changes from positive to negative, then it is a point of local maxima. If it changes from negative to positive, it is a point of local minima. So that is changing from positive to negative actually means we have x equal to 0. So we take a point which is left to the left of x equal to 0, which is to the left of 0, that is -1. We calculate f dash. Okay, we calculate f dash, not f. We sign of f dash of x we are checking. Okay, so we calculate f dash of -1, then we calculate f dash of 0, and then we calculate f dash of +1 or something to the right. Okay, so when it comes, if this is positive and this is negative, that means it changed from positive to negative. If this is negative and this is positive, it means it changed from negative to positive. So it is local maxima and minima accordingly. So if it is there is no change, both of are positive and both are negative, then the point is a point of inflection. Okay, so that's it. So that's how we do the first derivative test. We can take the example of x cube plus 1. Okay, we can take the x cube plus 1. So if this is the function, so we can actually do the second derivative test. Okay, so function f of x is equal to x cube plus 1. So second derivative test means we found f dash of x, that is 3x square, for it is 3x square, and f dash of x is equal to 0 means x is equal to 0. So x equal to 0 is the critical point. And after finding the critical point, we have to find the second derivative. So first we will be doing checking if second derivative works. Okay. So second derivative, that is f double dash of x is equal to 3 into 2x, that is 6x. And after that we will be substituting this value of x equal to 0. So that is f double dash of 0 is 0. So we got f double dash of 0 is equal to 0. That means that test is failed. Okay, so we don't know if it is a local maxima or local minima if the test is failed. So then we move to the first derivative test. So in first derivative test, this was needed. So we have x equal to 0, that is the critical point. So when x equal to 0, so when the function moves, the f dash of x moves from left to right. Okay, if it changes the sign. So we take a point left, that is x equal to -1. F dash of -1 is, that is 3 into -1 the whole square. 3 into -1 square, that is 3. And x equal to 1, that is f dash of 1, 3 into 1 the whole square, that is also 3. So in the number line 1, -1, 0, 1 was there. So here it was positive and here it was negative. So when it traveled through the 0, it had no sign change. Okay, it had no sign change. No sign change is there. That is, it is a point of inflection. Okay, I hope it is clear. And the last topic from this chapter we have is absolute maxima and absolute minima. So absolute maxima and absolute minima we find for closed intervals. If we are asked to find the maxima and minima for closed intervals, we will be doing this absolute minima, because for open intervals we don't know when does it really have this minimum value, because since it is closed we don't know where the point is. If it is saying 3, it doesn't mean 3 is not included, right? The upper limit is 3, that is 3 is not included. That means 2.9, we can't say that 2.9 is the upper limit. 2.99 can be there, or 2.999 can be there, etc. So we don't know the exact value. But for a closed interval which is like this, closed interval we know the upper limit is, of course, it is 3. So for closed interval, uh, the absolute maxima and minima, to find absolute maxima and minima, we calculate f dash of x, then we equate f dash of x equal to 0 and find the critical points, and then we evaluate the value of the function at these critical points and the endpoints. Okay, so for the function we had here, this x is equal to 0. So we will check for that on this. x cube plus 1, if we have x cube plus 1, we want to find the absolute maximum and minimum values. So on 0, 3. So there we have to find the critical point. So as we have found the critical point here is 0. So we have to find the function values at f of 0 and the endpoints. That is f0 is there, so f of 0 is there, and f of 1. So we find f of 0 and f of 1. That is f of 0 is 0 square plus 1, and f of 1 is 2. So which is greater? This is maximum value and this is minimum value. So this is the absolute minimum and this is the absolute maximum. Okay, so it's actually very simple. We just have to find the critical points and find the function values. Okay, so now let's move on to some problems, some previous year questions that have been asked from this chapter. Okay, so continuity, from continuity and differentiability, the most repeated type of question, that it's a must question, because for finding the value of k, so given that a function is continuous at some point, so a continuity condition is given there. So if in this question find the value of k, so that the function, there is a function defined here, it is given that the function is continuous at x is equal to pi. So what was the definition for continuity? It is limit extend to c minus f of x, that is LHL is equal to RHL is equal to f of c, correct? So if a function is continuous, LHL is equal to RHL is equal to f of c. So here the c, now we are checking the continuity at x is equal to pi. So pi is the continuity point. So we find LHL. Okay, the LHL here means the limit x tending to pi minus. Okay, here it is pi. Okay, so pi minus f of x. So limit x tending to pi minus. So what is the function value when pi minus? That is for the, this is the number line, this is pi. So pi minus belongs here to the left of pi. So that is, it is less than pi. So for all values that are less than pi, we have this function value kx plus 1. Okay, so kx plus 1 is equal to, now we apply this pi value. So we get that it is k pi plus 1. So LHL is equal to k pi plus 1. Now moving on to the RHL. RHL, we have limit x tending to pi plus f of x. Okay, so when x is tending to pi plus, that is for all those values that are to the right of pi, so x is greater than pi, right? So for the right of pi, we have the function value is equal to cos x. Okay, it is equal to cos x. So it is cos pi. What is the value of cos pi? Cos 0 is 1, so cos pi is minus 1. And yeah, so for a function, if a function is continuous, LHL is equal to RHL. Okay, so here k pi plus 1 is equal to minus 1. What we wanted to find? We wanted to find the value of k. Okay, so we are isolating k. So that is k pi is equal to minus 1, which is minus 2, and k is equal to minus 2 by pi. So k is equal to minus 2 by pi is the value. Okay, so what did we do? We just substituted what we know about continuity. We know that if a function is continuous, LHL is equal to RHL is equal to f of c. So we found LHL, found RHL, and then equated them and isolated k. Okay, it's that simple. Then find the value of k so that the function f of x is continuous at x is equal to 0. Okay, for x is equal to 0, we want to find the value. So here it is f of x. For x not equal to 0, the function value is this, and for x is equal to 0, the function value is k. Okay, so we want to find the function, we want to find what is k. So here also the basic properties, LHL is equal to RHL is equal to f of c. Okay, so here since this x is not equal to 0, so for x equal to 0, some other function, and for all the to the left and right, x not equal to 0 means x greater than 0 and x less than 0. So for both x greater than and less than 0, the function is having same value. So obviously the LHL and RHL will be, because to the left and right the function has same value. So LHL is equal to RHL. So we don't have to find them separately. So the limit, okay, limit these both LHL and RHL, we will be having limit x tending to how much? X equal to 0. We have to check the continuity at x equal to 0. So we limit x tending to 0 f of x. Okay, what is the f of x there? When it is tending to 0, that is, it is sine 5x by 3x plus cos x. Now, if we substitute the direct value, okay, of 0, we get sine 0, 0 and 3 into 0, 0. So, 0 by 0, which is not defined. 0 by 0, if you get an answer 0 by 0, that means you can't proceed that way. The answer is not defined. Okay. So, the limit do not exist. So, you have to change, you have to manipulate the function somehow. Okay, so I know that there is this property that I've learned in class 11, that limit x tending to 0 sin x by x is equal to 1. Okay, so I'm just going to use that property here. So here it is sin 5x, so I want to make it the denominator also 5x. It is 3x, so I want to make it also 5x. So if I want here 5, I can just multiply by 5 to the denominator. So if I multiply something to denominator, I want to multiply to the numerator also. So limit x tending to 0 sine 5x by 5x. Okay, I multiplied a 5 here and this 3 is removed over here, and numerator, on the numerator also, if I multiply some value denominator, on the numerator also I want to multiply. Okay, that's it. So I multiplied by 5 by 5 plus cos x. Okay, now we are applying this limit. So that means limit sin x by x is equal to 1 means limit x tending to 0 sin 5x by x is 5x is equal to 1. Okay, so this is 1 into 5 by 3 plus here also we have to apply the limit x tending to 0 cos x, that is cos 0 is 1. Okay, so that is 5 by 3 plus 1 implies 5 by 3 plus 3 by 3. Taking the LCM, we get 8 by 3. Okay, so we get the LHL and RHL as 8 by 3. And since it is continuous, we want to find f of c also, that is f of 0. What is f of 0? What is the function value when x is equal to 0? It is k. Okay, since they are continuous, we get that k is equal to 8 by 3, right? LHL is equal to, the limits are equal to f of 0, that is k is equal to 8 by 3. So that's what we wanted to find. We wanted to find the value of k, so we got k is equal to 8 by 3. Okay. Then find the values of lambda such that the function f of x is continuous at x is equal to 0. So function is continuous. It is also given that function is continuous at x is equal to 0. So we have this x not equal to 0 and x equal to 0, similar to the previous condition. So here also I am using that rule, limit x tending to 0 sin x by x is equal to 1. But here it is sine square, correct? So I am rewriting the equation, that is for x not equal to 0, for x not equal to 0, f of x is equal to sine lambda x the whole square, correct, by x square. So if this was the whole squared, okay, so if I can multiply by sine lambda x the whole square by lambda square x square, if there was a lambda square here, I could write lambda x by lambda x the whole square, correct? So I could write this. So that's why I multiplied a lambda square to the denominator. So if I multiply to the denominator, I have to multiply to the numerator also into lambda square. So into lambda square. So that is equal to sine lambda by, so now we will be applying limits. Okay, applying limits. So we get limit x tending to 0 sine lambda x by lambda x the whole square into lambda square, that is this is 1 into lambda square. Okay, so lambda square is the value there, and we want to find the f of 0 value. Okay, f of 0, for f of 0 when x is equal to 0 the function is having value 1. Okay, now since the function is continuous at x equal to 0, at x equal to 0, we get that f of 0 is equal to the LHL, which is equal to the RHL. Okay, so here f of 0 is 1 and LHL and RHL is lambda square. So lambda is equal to plus or minus 1. So that's what we wanted to find the values of lambda. So we got the value of lambda by lambda equal to plus or minus 1. So this rule you actually have to know. Okay, you have to know this equation. It will be very helpful. So in any cases, here also if we had directly substituted the lambda tending to 0, so we would have got that 0 by 0 form. So if you get the 0 by 0 form, you shouldn't proceed that way. You have to manipulate the equation. You have to change the equation to some other way so that it won't be 0 by 0. So we will get the limit. Here, find the value of k so that the function f of x is differentiable at x equal to 0. So differentiability, we are discussing differentiability in this question. So what was the differentiability equation? Yeah, LHD is equal to RHD. If LHD is equal to RHD, then the function is differentiable at that point. So it is given that the function is differentiable. Correct. The function is differentiable. That means LHD is equal to RHD. So LHD, we can find the LHD. So LHD, from the definition, we have LHD. LHD is, how do we find LHD? It is limit h tending to 0 f of c minus h plus, sorry, minus f of c by minus h it is. Okay, so we are finding, so limit h tending to 0 f of c minus h, that is here we had what was c, 0. Okay, we are going to find the value of c. So f of 0 minus h is minus h, so f of minus h minus f of 0 by minus h is equal to limit h tending to 0. F of minus h is what? For f of h, that is it is tending to, it is a left hand limit, so for the left hand it is kx. Okay, so for for k, for x less than or equal to 0 it is kx, so it is minus h, so k into minus h minus f of 0, for f 0 it is x square, so it is 0 by minus h. So opening this, we can get limit h tending to 0 minus kh by minus h. So this minus and minus cancel, h and h will can cancel, and after applying the limits we get k. Okay, because there is no h pending there, we will get the answer as k. And for the right hand derivative, limit h tending to 0 f of c plus h minus f of c by h is equal to limit h tending to 0 f of c, here is 0, 0 plus h minus f of 0 by h. So f of 0 plus h, okay, that is this is a right hand limit. So when it is x is greater than 0, that is on to the right, the function has x square value. So limit h tending to 0, f of h means h square. H square minus f of 0 is 0 by h, that is this h and 1 get h will get cancelled, that is limit h tending to 0 h, that is 0. H tends to 0 means it is 0. So since the function is differentiable at x equal to 0, we have that LHD is equal to RHD. That means k is equal to 0. That's what we wanted to find. We wanted to find the value of k. So we just did this. So these questions are very important. This will be definitely asked in your board exams, that is in the, especially in the MCQ sessions and all. This is a MCQ type question. So f of x is equal to mod x plus mod x minus 1, then which of the following is correct? Okay, so if we want to know the function is continuous and differentiable and all, So one thing you have to know is modulus function is continuous everywhere. Okay, modulus function is continuous everywhere. Continuous, there is no doubt about that. It is continuous everywhere. So not continuous, these option we can completely neglect. Okay, so modulus function is continuous everywhere. So for differentiability, it is almost differentiable everywhere, but whenever the function is not differentiable, whenever the modulus value, the function inside the modulus becomes 0. So here we have actually two functions, right? F and g. So it is f plus g is our function. So modulus x. So this function is not differentiable when x is equal to 0. Whenever the function inside this modulus, the value inside the mode becomes 0, the function is not differentiable there. The graph will be then a sharp graph at that point. We don't want a sharp graph, we want a smooth graph in order to get this differentiability. So the function is not differentiable when x is equal to 0. Then we have this also modulus x minus 1. When does this value become 0? X minus 1 becomes 0 when x is equal to 1. So the function is not differentiable when x is equal to 1. So the function is continuous everywhere, but the function as a whole, modulus x plus modulus x minus 1, this is not differentiable at x equal to 0 and x equal to 1. Okay, so which is the correct answer? It is differentiable. It is differentiable at, it is continuous at x equal to 0 and x equal to 1, but not differentiable at these points. Okay. The next question, differentiate e raised to sine square x with respect to cos x. So always we were asked to differentiate a function e raised to sine square x with respect to x, correct? So here we have asked that we have to differentiate it with respect to cos x. Okay, we have to differentiate a function with respect to another function. So this is a classic question. So here what we have to do is we have to see these two functions, that is u is equal to e raised to sine squared x and we have v is equal to cos x. We named them as two functions, and what we are doing is differentiating them. What we know is just differentiating them with respect to x, correct? So we are doing what we know, so that is differentiating both of them with respect to x. So du by dx is equal to, what is the differential of e raised to sine square x? You have to use the chain rule here. Okay, so for e raised to, for d by dx of e raised to x is e raised to x itself. So e raised to sine squared x into, chain rule is there because here it is not x, it is sine square, another function is there. So sine square, the outer function is square. So for a square function, the differential is 2 sine x. Okay, into sine x. What is the differential of sine x? It is cos x. Okay, so e raised to sine square x into 2 sine x cos x, that is du by dx. And what is dv by dx? Differential of cos x is minus sine x. Now what we wanted to differentiate e raised to sine square x with respect to uh, cos x, correct? This is what we wanted to do, that is du by dv. We wanted du by dv. So du by dv, forgetting that we write du by dx. We know du by dx by dv by dx. So now this is like in the form where we did these parametric forms. Okay. So now we just substitute. We know du by dx is what? 2 sine x cos x e raised to sine square x by dv by dx is minus sine x. So here the sine and sine will get cancelled and minus 2 is there. So minus 2 cos x e raised to sine square x is the answer. Okay, so this is how you differentiate a function which is a function with respect to another function. Okay, we consider it as two different functions and differentiate them accordingly and then take their ratios. Okay. This is another question in the same way. You have to try it on your own. Here also you have to differentiate this x raised to sine inverse x with respect to sine inverse x. So you have to take u is equal to x raised to sine inverse x and v is equal to sine inverse x. Then find du by dx and dv by dx and find the value of du by dv. Okay, let me know in the comments if you have able to do that. Now another question, y is equal to log x raised to x plus x raised to log x. This is where we have been using that logarithmic differentiation. So as I've said earlier, we use logarithmic differentiation when they are like one function power. Okay, the two functions are there. So one is power and the one is base. So for such function here also, here we have a function log x and its power is another function x. Here we have an x function and log x. So there we have to do logarithmic differentiation. Okay, if the power and the base, both of them are f of x raised to f g of x, both are functions, then we have to do this logarithmic differentiation. So for that we have to take log first on both sides, logarithm on both sides. So what are we doing? So naturally we will be tending to take the logarithms directly. So that is log y is equal to log of this function plus this function. So if we do this, so this is, suppose this is u and v, okay, this is u and this is v. So if we take logs directly, we get this form log u plus v. What is the expansion of log u plus v? Do we know that? We don't. All we know is that log AB is equal to log A plus log B. It's the product inside the log. We don't know anything about this. So we can't directly apply this log. Okay, if we do that, we won't be able to split it. We can't write log U plus log V. No, log U plus log V is log UV, not log U plus V. So we can't do this way. So we have to separately take logarithms. Okay, that is, we are taking u is equal to log x raised to x and v is equal to x raised to log x and separately finding the du by dx and dv by dx. So definitely y is equal to du by dx, dy by dx is equal to du by dx plus dv by dx. We can do that because this is a differentiation problem. Okay, for y is equal to u plus v, dy by dx is equal to du by dx plus dv by dx. So we are taking this separately. Okay, why? Because we can't apply the rule here. There is no rule like here. This, there is no log u plus v rule. Okay, so doing that, so log, we took log u is equal to log x, v is equal to log x raised to log x. So I'm going to find du by dx here. So for that, first we have to take log on both sides. That is log u is equal to log of log x raised to x. So from using that rule of logarithms, that is log a raised to n is equal to n log a, what we can write here, we can put that x down. So x into log of log x. Now differentiating this both sides. Okay, differentiating on both sides, we get differential of log u is 1 by u and differential of u is du by dx. Chain rule, we have applied the chain rule there. Here it is the product rule. Okay, x into log of log x. So x into log x, product rule. So we keep the function x right there. So differential of log x is 1 by log x into, again chain rule is there, for the log x the differential is 1 by x. Okay, and this x and this will get cancelled. Now plus chain rule. So now keeping log log x right there, and differential of x is 1. So 1 by log x. Now, yeah, du by dx, we wanted du by dx. So for this u, we transpose to the other side. So 1 by log x plus log of log x into u. Okay, what was u? Log x raised to x. Log x raised to x. So this is equation number 1. So now we got du by dx. Now we are going to find dv by dx. So for that we have x is equal, v is equal to x raised to log x. So taking logarithm on both sides, we can write log v is equal to log x raised to log x. So using the same rule of log a raised to n is equal to n log a, what we're doing is putting this log x down. That is log x into log x. Log x into log x means log x the whole square. Okay, now differentiating. So differential of 1 log is 1 by, okay, log x is 1 by 1 by x. So for log v it is 1 by v. Differential of v is dv by dx. So chain rule applied there. Now log x the whole squared. So for that the outer function is 2. So it is 2 log x into the inner function, it is log x. Log differential of log is 1. Sorry, 1 by x. So the 2 log x by x. Then what is dv by dx? So dv by dx is equal to 2 log x by x into v, x raised to log x, x raised to log x. Actually we can cut this x and log x, right? Or by using that law of exponential, that x raised to a by x raised to b is x raised to a by b. So here it is log x and 1. So we can write log x minus 1. You write a and b as the power, so a minus b. Here we have log x and 1 as the power, so log x minus 1. Okay, we can use that. So on simplifying, I get 2 into log x into x raised to log x minus 1. Okay, that is dv by dx. Now for finding, we wanted this differential, that is dy by dx. Just combining them. Dy by dx, as we have said, it is du by dx plus dv by dx. So that is equal to du by dx is 1 by log x plus log x into log x raised to x, log x raised to x. Just substituted the value from here, and this is equation number 2, that is dv by dx, plus just substituting that also we get the answer, x raised to log x minus 1. So this is the final answer. So this is how we do the logarithmic differentiation, and this was a special case because we couldn't directly apply the logarithm because we don't have this form log u plus v. So we splitted them as u and v. We differentiated it separately and then added them. Okay. Then see here also in this question, which was the homework. So here also when we want to find du by dv, here this is a function and the power is also a function. So there also you have to apply the logarithmic rule. Okay. So on applying that logarithm, we get log u is equal to log x raised to sine inverse u, and on applying the rule we get sine inverse x into log x. So that's it, and then differentiate. Okay, the remaining is left for you as an exercise. So this will be an exercise for both of these previous two types of problems. Now yeah, this is a important question. This type is an important question type. So why, if y is equal to a function, prove that this. So if we have y, we want to prove this. Okay, this is from the second derivative applications and all. So we have d square y by dx square. We want to get that. Okay, we have y, we want d square y by dx square and dy by dx. Just find it. Okay, if you know how to differentiate them properly using chain rule, product rule, or whatever rule it is, find it and substitute it directly. It's that simple. So we have y is equal to log x plus root of x square plus a square. So dy by dx is, what is the differential for log? It is d by dx of log x is 1 by x. So here for x it is this much. So we write that 1 by x plus root of x square plus a square into chain rule. We have to apply the chain rule. So we differentiated this, and now we are going inside the bracket. Okay, so the function inside the bracket, we want to differentiate this term. So x plus, the differential of x is 1 plus differential of root x. So these are some of the standard differentials, okay, which you can always remember. D by dx of root x is 1 by 2 root x. Okay, it is good that if you by heart some of these values. This just came from how did came root x can be represented as x raised to 1 by 2. So its differential is 1 by 2 x raised to 1 by 2 minus 1, that is minus 1 by 2. So that means 1 by 2 root x. That's how we got it. So no need to find it always. Just learn this. D by dx of root x is 1 by 2 root x. Okay. So here also d by dx of root. Okay, the root value, that is we get 1 by 2 root inside what is x there? X square plus a square. Okay. X, we have to keep whatever it is inside the root as that. Now into differentiating that term inside that root. Okay, x square, differential of x square is 2x and plus 0. Okay, now this 2 and 2 will get cancelled. So on opening this, it is 1 by x plus root of a square, x square plus a square into, here what remains, x is remaining, 1 plus x by root of x square plus a square is remaining. Now taking the LCM in this right bracket, keeping this first bracket as it is, and taking the LCM, it is x square plus a square. Now plus x by root of x square plus a square. So that is equal to, see, this quantity and these are the same, so they will get cancelled. So 1 by root of x square plus a square. So 1 by root of x square plus a square is the dy by dx. Okay, the differential, first differential is 1 by root of a square, x square plus a square. We want d square y by dx square also, that is we want to differentiate it once more time. Okay, so d square y by dx square is equal to d by dx of 1 by root x. So what was the differential of 1 by x? D by dx of 1 by x is minus 1 by x square. That we got because 1 by x is x raised to minus 1. So x, the differential of this is minus 1 x raised to minus 1 minus 1, that is minus 2. Okay, that is minus 1 by x square. Okay, so here in the place of x we have root. Okay, so it is minus 1 by root of x square plus a square whole square. Okay, so d by dx of 1 minus 1 by x square. Here in the place of x we had this whole term. So I just substituted the whole term and then the square to it. Okay, so minus 1 by that term, the whole square. Okay, now chain rule is there, so we have only did 1 by. Okay, we have only differentiated that 1 by, that fraction. Okay, now we have something inside that, instead of x it was root. So what is the differential of root? It is 1 by 2 root x, that is 2 root x square plus a square into, now inside the root it is 2x. Okay, so this 2 and 2 will get cancelled. Now what is remaining? Minus 1 into 1 into x, that is minus x by, in the denominator it is root of, no, this term will get squared. So this root and square will get cancelled. So our term is x square plus a square into root of x square plus a square. So that this is x raised to 1 and this is x raised to 1 by 2. Correct. So x raised to 1 plus 1 by 2, it is using the law for exponentials. X raised to 1 into x raised to 1 by 2 is x raised to 1 plus 1 by 2. That is x raised to 3 by 2. Okay, so here instead of x, we have this big term. Okay, so we are doing that minus x by x square plus a square the whole raised to minus 1 by 2. So my whole raised to 3 by 2. Okay, so that is our d square y by dx square. Now we want to check if this is true. So let's write it down. X square plus a square into d square y by dx square plus x into dy by dx. X into dy by dx. We want to prove that this is equal to 0. Now we have dy by dx and d square y by dx square. So I am going to do that. So x square plus a square into minus x by x square plus a square the whole raised to 3 by 2 plus x into 1 by root of x square plus a square. So here we have a complete x square plus a square, and here we have 3 by 2. 3 by 2 is, as we have said this before the step, it was x square plus a square into root of x square plus a square. So this x square plus a square and the one inside will get cancelled, and the remaining is only this root term. Okay, this gets cancelled here. So the only remaining is this term. So what we get, minus x is there by this and one of this term is cancelled. So it is x raised to square plus x square a square root. Okay, plus x by root of x square plus a square. Now look, this is the same numbers but different sign, minus and plus. So it is equal to 0. They will get cancelled off. So it is equal to 0. So we got RHS. So when we got LHS, when we took LHS, we got RHS. So that's it. Okay. Now let's do some of the problems from applications of derivatives. Find the values of a for which the function f given by f of x equal to sin x minus ax plus b is strictly increasing on the set of all real numbers r. So it is given that this given function is strictly increasing. Okay, it is given that condition. Now we want to find the value for a. So when is a function, what is the condition for strictly increasing? So if a function is strictly increasing, if a function is strictly increasing, it means that the f dash of x is greater than 0. Okay, a function is strictly increasing, it is by definition f dash of x is greater than 0. So we can find the f dash of x. So it is given f of x is equal to sin x minus ax plus b. So f dash of x is differential of sin x is cos x minus ax. A is a constant, so a into x into 1. Okay, so it is given since the function is strictly increasing, we can write f dash of x is greater than 0. So we have f dash of x as cos x minus a is greater than 0. That means cos x is greater than a. Okay, that is, or we can a is less than cos x. Okay, so we wanted to find the values of a. So cos x, as we know, cos x can have values always between 1 and minus 1, correct? The lowest value cos x can have is minus 1. So we have a which is even lesser than cos x. So a is less than cos x. So the lowest cos x can go is minus 1. So comparing both this equation, we get that a is less than cos x. So my a is less than minus 1 also. Okay, so we get a less than minus 1. So for all these values which are a less than minus 1, our function is increasing function. Okay, that's it. So we just used the definition, proper definition of what a strictly increasing function is. Okay, that's it. Okay, next question. Okay, this is a case study based question which is a classic question from this chapter. Okay, an environmental engineering firm is monitoring a water reservoir. The volume of water V in cubic meters in the reservoir at the time t in hours is modeled by a function. So V of t, we have given a function V of t. What does this V of t represent? It represents the volume of water in an environmental engineering firm. Okay, so we want to find the rate of change of volume with respect to time at t is equal to 3 hours. So rate of change, okay, we want to find the rate of change. Rate of change, usually what, how we do it, we differentiate it, d by dx or d by dt. Okay, here we want to differentiate what, rate of change of volume. Okay, so it is, we are differentiating volume, okay, with respect to t, okay, with respect to time t. So if we find dv by dt and put t is equal to 3, we get the answer of the first question. It is that simple. Okay, it's just a basic rate of change. How do we just want rate of change means differential. Okay, how to find the rate of change? Just differentiate the function. If nothing is mentioned, if like with respect to a t is not mentioned, you can always differentiate it with respect to t. Rate means it is with speed. Okay, speed is distance by time, or however it is with respect to time we are calculating. So differentiating with respect to time, unless it is said in the question. If we have said in the question differentiated with respect to distance, then you have to do so, but unless that's said, you have to differentiate it with respect to t. So here it is mentioned that we have to differentiate with respect to time, so it is d by dt, dv by dt, differentiate volume by dt. So let's do that. So for the first question, rate of change of volume is dv by dt. Okay, dv by dt, that is d by dt of 1 by 3 t square t cube plus minus 4t square plus 12t plus 100. This is the function we have to differentiate it. So 1 by 3 is a constant, 1 by 3 into 3t square minus 4 into 2t plus 12 into 1 plus 0. This is the differential. Okay. Now 3 and 3 will get cancelled. So t square minus 4 to 0, 8t plus 12. So this is dv by dt. So dv by dt is equal to dt square minus 8t by 12. And now we want to find when time is equal to 3. Okay, when 3 hours. So when t is equal to 3, that means here we want to substitute t is equal to 3. Okay, that is 3 square 9 minus 8 into 3, that is 24 plus 12. Correct, plus 12. So 12 minus 24, it is minus 12. So 9 minus 12, it is minus 3. So minus 3, volume is in cubic meters, it is given. So minus 3 meter cube per time, it is in hours. Okay, so this is how we find the rate of change. You have to be careful when you put this unit, because what is given, volume, different unit of volume, it is given, it is cubic meters upon hours. Time is also given in hours. Okay, so that's what we have to do. So what does this mean? This, the rate of change here, it is minus 3. Okay, uh, it means that the water is decreasing. Correct. If the rate of this is not as in the question, but something you can understand, if the rate of change is negative, that means it is decreasing. And if the rate of change was positive, it means they are increasing. So here it is negative, that is the water level in the reservoir is decreasing. Okay. Now the another question, find the time interval during which the volume of water in the reservoir is strictly decreasing. So this is the volume, we have the volume function. We want to find when this function is strictly decreasing. Okay, so when does the function is strictly decreasing? That is f dash, when f dash of x is less than 0, the function is strictly decreasing. When this is question number 2, when the function is strictly decreasing, we have f dash of x less than 0. Okay, so we have f dash of x right here that we have found, that is t square minus 8t plus 12. So t square minus 8t plus 12 is less than 0. We want to find the values of t. Okay, so what are the values of t? T here it is opening it using that properties of sum and product. So we want to find two numbers such that the sum is minus 8 and product is 12. Okay, so product is 12. So the two numbers are, just when you think about it, this is minus 6 and minus 2. So sum of minus 6 and minus 2 is minus 8 and the product of minus 6 and minus 2 is 12. So we can split it using splitting middle term. So t square minus 6t minus 2t plus 12 is less than 0. So taking t common from here, we get t minus 6, and taking minus 2 common from here, we get t minus 6 is less than 0. That is t minus 6 into t minus 2 is less than 0. So t is less than 6 and t less than 2. Okay, so that is the critical point here is 6 and 2. Okay, so we have 2 points here. Okay, this is minus infinity, infinity, and 2, 6 is marked there. So we want to find in which of these intervals is the function strictly increasing, strictly decreasing. So if I take any value from this, so from this infinity, minus infinity to, I can take 1. Okay, I'm just taking 1 and substituting in this first differential. Okay, so f dash of 1, it is 1 minus 8 plus 12. It is 1 minus, 1 minus 8 plus 12, it is 12 plus 1, 13, minus 8, it is 5. So this is greater than 0. So in this function, it is an increasing function. So in this bracket, it is an increasing function, increasing. Now in the second one, 2, 6, I am taking 3. Okay, any arbitrary number from that. So we have 3, 3 square is 9, minus 80 is the 8 is a 24 plus 12, so it is minus 3. So this is less than 0 here. So in this interval, it is decreasing. Now from this also, let's check f dash of 6 is over. So after 6 we can take 7. Okay, or whatever, 8 or anything. Okay, let me take 10. Okay, so 10 square, that is 100, minus 8 into 10 is 80 plus 12. Okay, so 100 minus 80 is 12, 20. 20 plus 12 is 20 plus 12 is 40, 32. So this is 32 is definitely greater than 0. So this is, in this also the function is increasing. So the where the function is increasing is the strictly decreasing is this second one. Okay, in the second interval, okay, the function is strictly decreasing in the interval 2, 6. Okay, now at what time t is the rate of decrease of water, the volume, what maximum. So rate of decrease of water volume, so what is that? Water volume's rate of decrease, that is rate of change in that is represented by dy by dt. So I want to know when does this volume, that quantity becomes maximum. So it's a problem of max finding local minima and local maxima. Okay, so for finding local minima and local maxima, how do we do the second derivative test? So I'm taking the second derivative. Okay, so d square v by dt square is, what was our first derivative? It was this t square. So differential is 2t minus 8t, we become 8. So the second derivative is 2t minus 8. And then what? Now we want to find what is t. So it is given that the volume is maximum. So if it is a maximum value, So it should be less than 0. Okay, so when 2t minus 8 is less than 0 means t is equal to 8 by 2, that is 4. So when time is 4 hours, we have the rate of decrease. So that's it. Okay, so in this question, we have dealt with the rate of change problem and the increasing decreasing problem and the maximum minimum problem. Okay, the maximum minimum problem we solved using the second derivative test. We already had this first derivative with us, so we did a second derivation also, and since it is given the volume is maximum, we just uh, equated it with the condition, that is it is less than 0. D square v by d x square is less than 0 when the function is maximum. So I got t is less than 4. Okay, next, find the absolute maximum and absolute minimum values of the function f given by f of x. So we want to find the absolute maximum. So it is very simple. These types of questions are very simple. Okay, absolute maximum. So we find the first derivative and then the critical point. Okay. So first derivative of this function is f dash of x equal to 2 into x cube into is 3x square. Okay, 3 2s are 6x square minus 15 into x square, it is 2x square, 2x. So 15 into 2x, it is 30x plus 36. Okay, so this is the first derivative, and to find the critical point, we want to equate it to 0. Okay, so when we equate it into 0, I can take, this is 30, so I can take 6 common outside, so I can have x square minus 5x plus 6 is equal to 0. So when this goes to the right side, I have the quadratic equation as x square minus 5x plus 6 is equal to 0. Now I want to split it, correct? Using the splitting, anyhow you want to find the value of x. Okay, using quadratic formula or whichever method you are comfortable with. So I'm going with the splitting the middle term formula format. So we want to find two terms such that its sum is equal to minus 5 and product is equal to 6. It is very simple, minus 3 and minus 2, right? Minus 3 minus 2 gives minus 5 and minus 3 into minus 2 gives 6. So we can split it. X square minus 3 x minus 2x plus 6 is equal to 0. So from this, taking x common outside, I get x minus 3 minus 2 outside, I get x minus 3. Okay, I have taken the minus also outside, that's why that's like that. Okay, so x minus 3 into x minus 2 is equal to 0. So I get x equal to 2 and 3. So on a number line, okay, it is 2 and 3. Okay, sorry. If it was an increasing decreasing problem, we had to do this number line thing, but our question was to find the absolute maximum and minimum. So we found the absolute maximum, the critical points x is equal to 2 and 3. Now we want to calculate the function values, that is at the end points and the critical points. The end points are 1 and 5 in the closed interval, so the end points are 1 and 5. So we want to find f of 1, f of 5, f of 2, that is the critical points, f of 3. Okay, let's do it. F of 1 is 2 plus 15, sorry, 2 minus 15 plus 36 plus 1. So it is 6 plus 1, 7 plus 2, 9, 39 minus 10, 29. It is 24. Okay, then f of 2, correct, f of 2, yeah, f of 2 is 2 2s are 2 into 2 cube, okay, minus 15 into 2 square plus 36 into 2 plus 1. Okay, so 2 cube is 2 2s are 4 2s are 8, 2s are 16. 16 minus 2 square, okay, 15 into 2, 30 into 2, it is 18. Okay, it is 60. Now plus 36 into 2, 6 2s are 12 and 3 2s are, so it is 72, and plus 1. Okay, so what is the answer? So adding this, we get 29. Now f of 3 we want to find. It is 2 into 3 cube minus 15 into 3 square plus 36 into 3 plus 1. So 3 3 are 9, 3 is 27 into 2. 54 minus 15 into 3 square, that is 15 into 3 is 135 plus 36 into 3 is 108 plus 1. So on solving this we get the value as 28. Now we want to find f of 5 also. F of 5 is equal to 2 into 5 cube minus 15 into 5 square plus 36 into 5 plus 1. So 2 into 5 cube, that is 5 is a 25. This 250 minus 15 into 25, 375 plus 36 into 5, it is 180 plus 1. Okay, so after solving this, so we get 56. So which among of this is the highest value? 56 is the biggest and lowest is 24. So absolute maximum is equal to 56 when at x is equal to 5, and absolute minimum is equal to 24 when x is equal to 1. Okay, then another case study based question. Sachin is a final year student at IIT Delhi. For his final year real time project, he has been given the job of designing an auditorium for cultural activities. The shape of the floor of the auditorium is a rectangle and it has a fixed perimeter. So P is a constant. It has a fixed perimeter, means P is a constant. Now, if L and B represent the length and breadth of the rectangular region, then find the relationship between L, B and P. So the first question, L, B and P, they are the length, breadth and perimeter. So we know what is the relation between perimeter, length and breadth. It is P is equal to, perimeter, P is equal to 2 into L plus B. Okay, so that is the answer for first question. Express the area A of the floor as a function of L. Okay, so area of the function is, as we know, area of a rectangle is length into breadth. So we want to express it as a function on L. Okay, here that is we want to change B in terms of L. So from this we have P is equal to 2L plus 2B. Correct? So from this what we get? B is equal to, that is 2B is equal to P minus 2L and B is equal to P by 2 minus 2. Sorry, P by 2 minus L. 2 and 2 will get cancelled there. So we have B. Okay, so I am substituting that B here. That is L into P by 2 minus L. And opening the, we get PL by 2 minus L square. Okay, so we expressed area as a function of L. Okay, it is done. Now third question, Sachin is interested in maximizing the area of the floor. For this purpose, find the value of L for which the area is maximum. So he want to maximize, we want to find the value of L when the area is maximum. So we have this area, we want to maximize the area, so we have to find dA, or using second derivative test or first derivative. So dA by dl, because we are differentiating it with respect to L. Correct? It is a area is a function in terms of L. So dA by dl is equal to d by dl of PL by 2 minus L square. So here in this first term, P is a constant, 2 is a constant. So P by 2 is a constant, I kept it there, and L is dl by dl is 1. Okay, differential of L is 1. So P by 2 minus, for 2 L square it is 2L. So P by 2 minus 2L. That is the first differential. So if we want to find the critical point, what do we do? To find critical point, dA by dL is equal to 0. That is, L by 2 minus 2L is equal to 0. Now we want to find the value of L. Correct? Sorry, this is P by 2. Sorry. P by 2. P by 2. P by 2 minus 2L is equal to 0. And we want to find the value of P by 2 is equal to 2L and L is equal to, this 2 comes here, so we get L is equal to P by 4. So L is equal to P by 4 is the critical point. Okay, let's, it is already given that it is maximum, but let us confirm if it is maximizing or not. So to know that, the second derivative test, that is d square A by dt dl square, I am differentiating it again. The differential was p by 12. So p by 2 is a constant, its differential is 0 minus 2 into L. That is 1. So minus 2 is the differential. So minus 2 is greater than 0. That means it is a maximum value. So this L, that means this critical point L is equal to p by 4 gives the maximum value for the area function. Correct? Okay, that is what we wanted to find. We wanted to find the value of L for which area is maximum. So when it is maximum, L is equal to P by 4. So for third question, the answer is L is equal to P by 4. And fourth question, find the maximum area of the auditorium floor in terms of P. Okay, so what was area? Area is equal to L into B, and now we got L is equal to P by 4 and B is equal to B is equal to P by 2 minus L. Okay, that we have already written from here. So P by 2 minus L. So P by 2 minus L is now P by 4. Okay, taking the LCM here, we get P by 4 into, that is 2P minus P by 4, that is 2 by P by 4 itself. Just took the LCM here. So that is P square by 60. So that is the answer. So I believe you all have understood this. So from this chapter, these kind of case study based questions are important that will be asked. So practice more and all the best for your exams. Thank you.